And in this project, I introduced RuleShift, a benchmark designed to evaluate whether AI models can detect silent rule changes without any feedback or not. So there is a six taxes, and in based on the six taxes, it will evaluate it. And for the time limitations, I used only the test data set, which is the 60 scenarios per test, per task. And I focus on the key limitations in current evaluation method. Most benchmark test static reasonings, but and among of them, in the evaluation times, it gives the feedbacks to the model. Some methods gives feedbacks at the last, or some gives in the middle, and some gives at the beginnings to the model. But in the rule shapes, there is no feedback. To address this, I define that matrix called RAL, that and it is the full form is that rule adaptation latency. Um, so it will detect that how models adapt when the underlying rule changes. In the real world, rule is changing very rapidly. Law and justice, and also in medical sector and other sectors, rule change most frequently. In those cases, models should understand that past rules is already ignored, or it is are not using, and new rules comes and it should be adapted. So in that case is how more quickly it is detected. So that is the main things here. The final leaderboard scores is the average RAL across six different cognitive tasks. So because of the times and cost limitations, so I uses the GPT, Clouds, and Qmans, and Gemini 3 Pro. Gemini 3.1 Pro sometimes did that. Uh, Sometimes it is the timeout issue, so I need to fix that. And another thing is that Q man sometimes generating that non-times objects. So I should look after that also. So in that cases, we can see that that text frequency taxes that perceptual, that is 0% minerals, and the valid is 40, and distribution in that it is so good, because when a meal is mineral if zero, then it is goods. Semantic is tense, because in the chat GPT, in the semantic tags are mostly failed, and procedurals, and there is also metrics you can see. Then mineral is theory. And also alongside minerals, the RAL metrics, I calculated those inventory controls or workings, memories, plannings, those are included. Alongside, there are other metrics are with this immediate detection rate, higher is better, IDR, DNF, did not finish rate, lower is better than ICR, in inhibitor control rate, higher is better, and then P1 accuracy, because in that phase one, there is a two limitation. When I'm testing, in that time, first times I thought to give that no is no bypass, totally strict rules. Like if it is failed one time, the whole scenario was excluded from the testing and the evaluation. So, and that's why it is the continuously failing, because five trials in per charts, it cannot determine and the correct answers perfectly, and cannot learn perfectly. So in that case, LLM is still backlagging, and here we need the updations. Another thing. When I'm testing, in that cases, after giving that when a model can give the answers or can learn um, more than uh, more than half of the number of tasks, or more than half of the number of the trials in one times. Like if I give the five trials, if it is learned that three trials, then it will include that scenario in that evaluation for the phase two. But when I use the strict that that five out of five it should be, that times it maximum scenarios are being excluded because models are not enough to learn still. And there is a part as score that is also given, the which rule shift and dimension structures all are documented. So that this project helps provide a more realistic evaluations of models and robustness and adaptability in dynamics environments. Because in real world, a human has that capability to think dynamically and also have the ability to adapt in the new environment. So, so AI models, if it is becomes and if it can adapt in those situations, so that we can get more intelligence and more genuine answers from that model. But that is also alignment with the AGI, because AGI is visions aligned with that how dynamically it can solve and it can learn with minimal data. Okay, when if a model can succeed in the rule shift benchmark, so that means it has the capability to learn quickly, and it has capability to learn in a small data set. Okay, so that is the another point, because nowadays we are training models with a huge data set, but humans no needed that much huge data set to learn um, mathematics and also other subjects. So in that cases, these rule shift benchmarks can play an important role. Thank you, everyone.